Okay, so what have we learned about design patterns in Solid? And you know what, unfortunately, design patterns it's one of these things that's hard to teach because you don't really appreciate them until you find yourself in a situation where you have a use for one. So usually the best we can do is show examples of these things in the wild and some plausible scenarios that might come up in the kinds of projects that you all are designing where some of these might arise. So we kind of tried to do this by looking at patterns that are prevalent in Rails because the one common denominator for all the projects here is you're all using it. So we saw examples like the adapter pattern, which is used to handle connections to different types of databases. That also uses the abstract factory pattern because you don't necessarily know until runtime what kind of database it's going to be. When we talk about performance and DevOps and how caching works, we'll see the specific implementation that allows caching to use the observer pattern. But again, that's a good example of observer because the idea that you're going to cache something is not a responsibility of the thing, but you need to know information about the thing's states or its behaviors in order to do caching correctly. We saw the use of the proxy object in something as simple as the association collections. They look and quack like enumerable collections, but they really aren't. Instead, it's a fairly complicated object with a sophisticated set of behaviors, including lazy query execution. We saw examples of using the Singleton pattern, but we didn't mention that one of the places it's used in Rails is the inflector. This is the thing that knows how to pluralize words in order to turn your convention over configuration to turn your names of models and things into database tables. There's only one inflector, and it collects all the rules. So when you use it, you call it by essentially calling some class methods. The decorator design patterns, when we did active record scopes, we saw that you could essentially stack scopes together. That's basically a decorator, right? We're taking something that has some existing behaviors, and we're interposing something that gives you the same API, but adds some additional behaviors on top of it. The command pattern is one that we didn't talk about in an example, but the command pattern is one that allows you to run commands that can potentially be recorded, replayed, undone. Migrations are kind of an example of that because you create these files showing what to do, and you can run up migrations, you can run down migrations, you can keep track of which ones you ran. So it's like having a command interpreter with very complicated commands. The iterator design pattern, we didn't even really talk about it because in Ruby it's everywhere, right? From day one, you've been using things like each to separate collection traversal from computation. In other languages, you have to go out of your way to use the iterator pattern by creating an iterator object and playing games with the type system to not make it mad at you. So what we've seen for a lot of these patterns is that duck typing simplifies how you express the design patterns. It usually requires fewer lines of code to get things done. In some cases, the implementation is particularly clean. Like in the case of observer, we didn't have to put new code into the customer source code in order to observe customer, because with Ruby's open classes, we can do that at runtime, right? We can use metaprogramming to do some of these things that you couldn't get away with in a statically compiled language. So we tried to show an example of a few of these in the wild. And as you write your own code, keep in mind that the pattern of design or the catalog of design patterns is growing all the time. Both the design patterns and the solid guidelines really came out of examples in statically typed languages. So some of the principles are in some sense easier to follow in statically typed languages because the cost of not following them is much more obvious. So for example, a lot of the design patterns in terms of minimizing the cost of change are trying to avoid situations where a simple change modifies the type signature and requires recompiling of a package. In Ruby, there's no compilation. So you're basically being shielded from a cost, right? You're being given some leeway to make poor design choices because in a statically typed language, you would realize it was a poor design choice because you have to recompile the world every time you make a simple change. And after a while, you start to think, gosh, is there a way to isolate the place where these changes live so that in the future, I don't have to recompile all these other modules just because I made this really simple change? So a lot of the solid principles really came out of that viewpoint. And there's a particular pitfall that in Ruby, those costs often are hidden from you until it's too late. So things that avoid recompilation, right? The design patterns are still valid. The solid principles are still valid. But you have to be a little more alert for when you might be violating them because the cost won't come up and smack you in the face like it does in other languages. So what will we sort of summarize about design patterns? And we haven't yet talked about how they're used in plan and document methodologies, but that's going to be next. The reason design patterns exist is that they came out of collections of problems where somebody realized, there's actually a commonality across these problems. We could write down a solution that we know works well. And working well means you get to maintainable code that minimizes the cost of change or minimizes gratuitous cost of changes. A few of the patterns, I say reified in Rails. They're sort of codified and they're deeply embedded in Rails because they're useful to software as a service, like the observer pattern. And you can apply the idea of patterns at many levels. So we saw at the very beginning of the class, there's patterns for software architecture. We've seen patterns for design, like the ones that we've just been talking about now. And there's patterns of computation, like types of computations that come up over and over again, and you can get libraries for them and stuff like that. In all cases, the goal is the same. It's to separate out things that change from things that stay the same. That minimizes the cost of changing the things that change. And we sort of saw like 4 rules of thumb, 4 principles that underlie a lot of the design patterns. Program to the interface, not to the implementation, right? So dependency injection says don't depend on implementation. Inject an abstract interface that both sides depend on, and that's where the dependency gets hidden. Prefer composition over inheritance. We saw that when you're trying to reuse behaviors, inheritance is not always the right way to do it and can even lead to problems like lack of Liskov substitutability. And many times, the better solution is to have composition, right? Have an object that has as its component an object of a more basic type and can then, in some cases, delegate behaviors to the more basic object. And all 3 of these, the expression of them and sort of the mechanics of how you do them are made easier by duck typing. This is sort of a couple of hours worth of introduction to a topic that literally volumes have been written about. And I think the best advice we can give is as you're doing these projects, keep an eye on your metrics, sort of be self-aware when you're changing code. You'll know, surprisingly often, you'll know that you're doing something wrong. It'll feel like there should be a nicer way to do this. And that's the point where you should stop and say, OK, let me take a step back. What's the problem I'm trying to solve? And might there be a design pattern that helps me solve it? OK, here's the last wrap-up question on the use of design patterns in Rails. So Active Record has this abstract adapter we talked about for connecting to databases. Abstract adapter has subclasses, one for each type of database that Rails works with out of the box, and you can add ones for new databases. And when you start your application, Rails will look in your config database.yml file, and it will figure out which is the correct subclass to instantiate to create an instance of for your app to talk to its database. So that's a nice set of behaviors there, and the question is, which of these 4 solid principles is not one of the ones that's illustrated in this example? Open-closed, dependency injection, Demeter, or Liskov substitution?